Hello students, so Wednesday, that means tomorrow, you are going to write exam. That is first is itself you are going to write science exam. That is English is there first exam. After that science exam you are going to write, that is 11:30 to 12:30. So as already discussed, so your question paper pattern will be like this. It's already sent. Question paper pattern. So but it is sent, it is sent I think in a little bit wrong way. No, it is correct, but marks mentioned is it went wrong, and class 9 science it is not there. It has written science class 9 Kannada like that. So your two portion will be like this: matter in our surroundings and motion. Matter in our surroundings. Matter in our surroundings, and second chapter is motion. Okay, and how many questions will come I will discuss. So there will be 3 1-mark question, 3 marks, and there will be 2 3-mark question, that is 3 marks. There will be 3 2-mark question, that will be 6 marks. So this is 6, so 6 6 12 3 5. So 1 5-mark question, 5 mark. So this will be 20 mark. So this will be 1 5-mark question will be definitely a numerical on motion, which is solved already. Exercise ಒಳಗಿರ್ತಕ್ಕಂಥ ಸಾಲ್ವ್ಡ್ ಕ್ವಶನ್ ಇರ್ತದೆ, ದಟ್ ಈಸ್ 5 ಮಾರ್ಕ್. ನಾವು ಆಲ್ರೆಡಿ ಸಾಲ್ವ್ ಮಾಡಿನಿ, ಸಾಲ್ವ್ ಮಾಡಿದ ಕ್ವಶನ್ ಇರ್ತದೆ. ಸೊ ಇಲ್ಲಿ 3 ಮಾರ್ಕ್ಸ್ 2 ಕ್ವಶನ್. ಸೊ ಯಾವ ಬೇಕಾದ್ರೆ ಕೇಳ್ಬೋದು, ನಾನು ಡೆಫಿನೆಟ್ಲಿ 1 ಡೆರಿವೇಷನ್ ಕೇಳ್ತಾನೆ ಮೋಷನ್ ಒಳಗಿಂದ. ಮ್ಯಾಟ್ರ್ ಇನ್ ಅವರ್ ಸರೌಂಡಿಂಗ್ಸ್ ಒಳಗೆ ಯಾವ್ದಾದ್ರು 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಇರ್ತದೆ. 2 ಮಾರ್ಕಿನ 3 ಕ್ವಶನ್ ಇರ್ತಾವೆ, 1 ಮಾರ್ಕಿನ 3 ಕ್ವಶನ್ ಇರ್ತಾವೆ. 2 ಚಾಪ್ಟರ್, ಮ್ಯಾಟ್ರ್ ಇನ್ ಅವರ್ ಸರೌಂಡಿಂಗ್ಸ್ ಆ್ಯಂಡ್ ಮೋಷನ್ದಾಗಿನ. ಓಕೆ, ಈಸಿ ಚಾಪ್ಟರ್. ರೆಸ್ಟ್, ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಸ್ಪೀಡ್ ಆ್ಯಂಡ್ ವೆಲಾಸಿಟಿ, ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಡಿಸ್ಟೆನ್ಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, difference between scalars and vectors. Okay, our type of matter in our define sublimation, give examples, define what is boiling point, define boiling point, what is the boiling point of water, define melting point, what is the melting point of ice. ಈ ಥರದ್ದು. ಓಕೆ, ಈ ಥರದ್ದು ಕ್ವಶನ್ಸ್ ಇರ್ತಾವೆ. ದೆನ್ ಮತ್ತೇನು ಹೇಳ್ಬೋದು, what is the physical state of water at 25 degrees Celsius, 250 degrees Celsius, 0 degrees Celsius. So define sublimation, define vaporization, factors affecting evaporation. So ಇವೆಲ್ಲವೂ ಇರ್ತಾವೆ. Okay, so now we will discuss or revise this chapter, matter in our surroundings. Okay, we will revise this chapter, matter in our surroundings. Okay, so the chapter starts with initially, so well, revision is almost like this. So what you have learned, and after that exercise we will do. So what you have learned, just we will go through that. Matter is made up of small particles, that we know. Matter is made up of small particles. So revision, matter in our surroundings. Matter in our surroundings. Okay, that one we will revise in this class. Okay, then matter is made up of small particles. The matter around us exists in 3 states: solid, liquid and gas. Of course, matter around us, it exists in 3 states, that is solid, liquid and gas. The forces of attraction between the particles are maximum in solids, intermediate in liquids and minimum in gas. See, the force of attraction between particles, what is that? They are maximum in solids. Force of attraction is in solids it is maximum, in liquids it is intermediate, in gas it is very less. Minimum we can say. The spaces in between the constituent particles and kinetic energy of the particles are minimum in case of solids, intermediate in liquids, maximum in gas. That is what you can say spaces. Gas ಒಳಗೆ ಏನಿರ್ತಾವೆ, if you take so solid ಇರ್ತಂದ್ರೆ so small ತಗೋಣ. Okay, this is like solid, ಎಲ್ಲಿ ಗ್ಯಾಪ್ ಇರಲ್ಲ. ಲಿಕ್ವಿಡ್ ಒಳಗೆ ಸ್ವಲ್ಪ ಗ್ಯಾಪ್ ಇರುತ್ತೆ. Okay, this is like liquid. Gas ಅಂತಂದ್ರೆ full gap. Okay, so solid, liquid, gas. So ಏನಾಯ್ತು, intermediate force of attraction ಕಡಿಮೆ ಇರ್ತದೆ, ಹೆಚ್ಚಿರ್ತದೆ. ಮೀಡಿಯಮ್, intermediate minimum. Space less, intermediate spacing is less, medium maximum. The arrangement of particles is most ordered in the case of solids. Solids are the most ordered. Okay, just like ordered. We have already discussed this. In the case of liquids, layers of particles can slip and slide over each other, while for gases, there is no order, particles just move out randomly. So ಏನಾಗ್ತದೆ ಲಿಕ್ವಿಡ್ ಒಳಗೆ ಏನಾಗ್ತದೆ layers of particles slip and slide over each other ಆಗ್ತಾವು, but there is no order and particles just move randomly in gases. Okay, the states of matter are interconvertible adavu states of matter. The states of matter can be changed by changing temperature or pressure. Temperature change ಮಾಡೋದ್ರ ಮುಖಾಂತರನು ಸ್ಟೇಟ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್ ಮಾಡೋದು, ಚೇಂಜ್ ಮಾಡೋದು ಸಾಲಿಡ್ ಟು ಲಿಕ್ವಿಡ್, ಲಿಕ್ವಿಡ್ ಟು ಗ್ಯಾಸ್, or ಪ್ರೆಷರ್ ಚೇಂಜ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರನು ಮಾಡಬಹುದು. ಓಕೆ, ಸಾಲಿಡ್ ಟು ಗ್ಯಾಸ್ ಯು ಕ್ಯಾನ್ ಸೇ. Sublimation is change of solid state directly to gaseous state without going through liquid state. Sublimation ಅಂದ್ರೆ ಏನು, ಸಾಲಿಡ್ ಇರ್ತದೆ ಡೈರೆಕ್ಟ್ ಏನಾಗ್ತದೆ ಗ್ಯಾಸ್ ಆಗ್ತದೆ without undergoing liquid state. So that is sublimation. Example is camphor and naphthalene balls. Deposition is a change of gaseous state directly to solid state without going through liquid state. ಈ ಗ್ಯಾಸ್ ಆಗಿದ್ದು ವಾಪಸ್ ಏನಾಗಬೇಕು, ಸಾಲಿಡ್ ಆಗಬೇಕು. ಅದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು ಡಿಪಾಸಿಷನ್ ಅಂತ ಕರಿತೀವಿ, ವಿದೌಟ್ ಅಂಡರ್ ಗೋಯಿಂಗ್ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್. ಬಾಯ್ಲಿಂಗ್ ಇಸ್ ಅ ಬಲ್ಕ್ ಫೆನಾಮಿನಾ, ಪಾರ್ಟಿಕಲ್ಸ್ ಫ್ರಮ್ ದ ಬಲ್ಕ್ ಆಫ್ ದ ಲಿಕ್ವಿಡ್ ಚೇಂಜ್ ಇನ್ ಟು ವೇಪರ್ ಸ್ಟೇಟ್. ನೋಡಿ, ಬಾಯ್ಲಿಂಗ್ ಅಂದ್ರೆ ಬಲ್ಕ್ ಫೆನಾಮಿನಾ. ಸೊ ಇದೇನಾಗ್ತೈತಿ, ಬಲ್ಕ್ ಎಲ್ಲ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಾವೆ ಒಮ್ಮೆ ವೇಪರ್ ಸ್ಟೇಟಿಗೆ ಹೋಗ್ತಾವೆ. ಬಟ್ ಇವಾಪರೇಷನ್ ಹಂಗಲ್ಲ. ಇವಾಪರೇಷನ್ ಇಸ್ ಅ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನಾ. ಸರ್ಫೇಸ್ದಾಗ ಇದ್ದು ಅಷ್ಟೇ ಏನಾಗ್ತಾವೆ ನೇಚರಿಗೆ ಹೋಗ್ಬಿಡ್ತಾವೆ, ಸುತ್ತಿರ್ತಕ್ಕಂಥ ಎನ್ವಿರಾನ್ಮೆಂಟಿಗೆ ಹೋಗ್ಬಿಡ್ತಾವೆ. Evaporation is a surface phenomenon. Particles from the surface gain energy to overcome the force of attraction present in the liquid and change into the vapor state. So ಏನದು ಇದರೊಳಗೆ ಇರ್ತದಲ್ಲ, ಇದು ಇರ್ತದ ಸರ್ಫೇಸ್. ಸೊ ಇವೇನು ಮಾಡ್ತಾವು, ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ದಿಂದ ಹೊರಗೆ ಬರಬೇಕಾದ್ರೆ ಸರೌಂಡಿಂಗ್ ಇಂದ ಎನರ್ಜಿ ತಗೊಂಡ ಸರೌಂಡಿಂಗ್ ವಾಪಸ್ ಹೋಗ್ತಾವೆ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ evaporation. What are the factors affecting the evaporation or the rate of evaporation? The rate of evaporation depends on 4 factors: the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed. This is very much important. Factors affecting evaporation. For 2 mark or 3 mark, this is very much important. Evaporation causes cooling. Evaporation ಆಗೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, ಕೂಲಿಂಗ್ ಆಗುತ್ತೆ. ಮುಂದೆ ನೀವೇನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ವಾಟರ್, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ವಾಟರ್ ಕಂಪಲ್ಸರಿ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಮುಂದೆ ಕನ್ವರ್ಷನ್, degree Celsius to Kelvin, Kelvin to degree Celsius, that is there, you can see that. So these two are important. Definition: latent heat of vaporization is the heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point. At its boiling point ಏನು ಮಾಡಬೇಕು, 1 kg ಲಿಕ್ವಿಡ್ ಇದ್ದದನ್ನ ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗಬೇಕದು. ಓಕೆ, ಸೊ ಅದು ಏನಾಗ್ತೈತಿ, 1 kg ಲಿಕ್ವಿಡ್ ಇದ್ದದ್ದು ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗಬೇಕಾದ್ರೆ ಅದಕ್ಕೆ ಎಷ್ಟು ಹೀಟ್ ಕೊಡ್ಬೇಕು ನೋಡ್ರಿ, ದಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಲೇಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಇವಾಪರೈಜೇಷನ್. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ, ಲೇಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಇವಾಪರೈಜೇಷನ್ ಅಂತೀವಿ. ಲೇಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಫ್ಯೂಷನ್ ಅಂದ್ರೆ ಏನಾಗ್ತದೆ ಹೇಳ್ರಿ, ಸಾಲಿಡ್ ಟು ಲಿಕ್ವಿಡ್ ಆಗ್ತಿರ್ತೈತಿ. ವೆಪರೈಜೇಷನ್ದಾಗ ಲಿಕ್ವಿಡ್ ಟು ಗ್ಯಾಸ್ ಆಗ್ತಿರ್ತೈತಿ. ಸೊ ಅಲ್ಲೆಷ್ಟು ಡಿಫ್ರೆನ್ಸ್. ಲೇಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಫ್ಯೂಷನ್ ಈಸ್ ದ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ಚೇಂಜ್ 1 kg ಆಫ್ ಸಾಲಿಡ್ ಇಂಟು ಲಿಕ್ವಿಡ್ ಅಟ್ ಇಸ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. 1 kg ಆಫ್ ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ಕೊಡ್ಬೇಕಲ್ಲ, ಅದಕ್ಕೆ ನಾವು ಲೇಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಫ್ಯೂಷನ್ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. ಆಟ್ ಇಟ್ಸ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್, ವೆಪರೈಜೇಷನ್ ಆಟ್ ಇಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಸೊ ನಾವು ವಿ ವಿಲ್ ಸಿ ದ ಕ್ವಶನ್ ಆನ್ಸರ್, ದಟ್ ಈಸ್ ಎಕ್ಸರ್ಸೈಸ್. ಸೊ ಇಲ್ಲಿ ಕ್ವಾಂಟಿಟಿ ಮತ್ತು ಯೂನಿಟ್ ಅದಾವು, ಅವನ್ನ ನೆನ್ಪಿಟ್ಕೊರಿ. ಟೆಂಪರೇಚರ್ ಕೆಲ್ವಿನ್, ಲೆಂತ್ ಅಂದ್ರೆ ಮೀಟರ್ ಹೊಗಳಿತೀವಿ, ಅದರ ಸಿಂಬಲ್ ಎಮ್, ಕೆಲ್ವಿನ್ ಅದು ಕೆ, ಮಾಸ್ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ಕಿಲೋಗ್ರಾಮ್, symbol is kg, weight expressed in Newton, symbol N, volume in cubic meter, meter cube, symbol, density is in kilogram per cubic meter, that is kg per meter cube, pressure, SI unit is SI unit of pressure, these all are SI units. SI units of pressure is Pascal, either represent ಮಾಡ್ತೀವಿ PA. Exercises: convert the following load with the pattern 1 mark 3, 2 mark 3 mark 2, 1 mark 5. ಓಕೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ 90% ಕ್ವಶನ್ ಅನ್ನು ಎಕ್ಸರ್ಸೈಸ್ ಒಳಗೆ ನಾವು ಹಾಕ್ತೀವಿ. 90% ಈ ಚಾಪ್ಟರ್ಗೆ ಸಂಬಂಧಿಸಿದ 90% ಕ್ವಶನ್ಸ್, ನಾಟ್ ವಿ ಕೆನಾಟ್ ಸೇ 90%, ಸೇ 80% ಕ್ವಶನ್ಸ್ ಐ ವಿಲ್ ಆಸ್ಕ್ ಫ್ರಮ್ ದಿಸ್ ಎಕ್ಸರ್ಸೈಸ್ ಓನ್ಲಿ. ಓಕೆ, ಸೊ ಬಟ್ this exercise only 70 to 80% question I will ask. In motion I will ask not from, I may ask from exercise, I may not ask from exercise, but very very important questions I will ask. Difference between speed and velocity, define speed, define acceleration, write its SI unit, difference between distance and displacement, difference between scalars and vectors, and one numerical, that is solved example of the textbook. Textbook ಒಳಗೆ ಇರತಕ್ಕಂಥ solved example I will give you. Okay. So now we will give you one solved example and one derivation for 3 mark. Exercises. Convert the following temperature to the Celsius scale. 293 K, 470 K. So 293 K and 470 K. So 293 K ಐತಿ ಇದನ್ನ ಏನು ಮಾಡಬೇಕು ಸೆಲ್ಸಿಯಸ್ ಒಳಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಇದರ ಮೈನಸ್ 273 ಮಾಡೋದು ಸೊ 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಇದು 470 K minus 273 ಮಾಡ್ರಿ so we will get 197 Celsius. Convert the following temperatures to the Kelvin scale. 25 degree Celsius ಐತಿ ಅದು plus 273 ಮಾಡಬೇಕು 298 ಆಗ್ತೈತಿ 373 ಐತಿ plus 273 ಮಾಡಬೇಕು ಹೌದಲ್ಲ ಭಾಳ 573 373 273 6 4 6 646 degree Celsius 646 degree Celsius. Okay, give reasons for the following. Observation. Naphthalene balls disappear with time without leaving any solid because naphthalene balls are undergoing sublimation. If they undergo sublimation, they don't leave any solids, they will directly go vaporization. We can get the smell of perfume sitting several meters away. We have already discussed, I have sent all answers also. So we can get the smell of perfume sitting several meters away because of diffusion. Okay, because of the diffusion process we can say. Arrange the following substance in increasing order of force of attraction between the particles: water, sugar, oxygen. Force of attraction is more in solids. So they are in increasing order means we have to take lower first. Oxygen is very less. Oxygen, next intermediate water, next maximum, that is sugar. What is the physical state of water at 25 degrees Celsius? It will be in liquid state. 0 degrees Celsius, see here, in 0 degrees Celsius it can be in solid or it can be in liquid. In 100 degrees Celsius same, it can be in liquid or it can be in gaseous state. Give 2 reasons to justify. Water at room temperature is a liquid. See, water at a room temperature is liquid. 2 reasons, because at room temperature water flows at room temperature. 2 properties of liquid you write. At room temperature water will not have any fixed shape but it has fixed value, so it is water at room temperature liquid. Same thing, an iron almara is a solid at room temperature. Same, the force of attraction between iron alma is maximum at room temperature. It is having fixed shape and fixed boundary or fixed value in room temperature, so it is a solid at room temperature. Seventh one, why is ice at 273 K more effective in cooling than water at the same temperature? Because ice is having latent heat of fusion also, that is why it is more effective in cooling than water at the same temperature. 8th question, what produces more severe burns, boiling water or steam? See, boiling water or steam? Steam is having more temperature compared to boiling water, and steam is having that latent heat of vaporization with it also. So that is why latent heat of vaporization with it also. That is why steam produces more severe burns. So 9th one, name ABCDEF in the following diagram showing change in its state. So A, you can say solid to liquid, fusion or melting. Liquid to gas, vaporization. B, solid to gas to liquid, that is C. What we can say for that? So liquid to solid, that is solidification we can say. Gas to liquids we can say condensation. Then E, directly solid to gas, sublimation. Gas to solid, F, that is deposition. So these are the things we discussed here. So please, my dear students, maximum refer the exercise of matter in our surroundings and factors affecting evaporation, that is very much important. See, just I will go through some important questions, that is factors affecting evaporation. Then after this, definition of sublimation, definition of vaporization, definition of boiling point, definition of melting point, definition of latent heat of vaporization, definition of latent heat of fusion. These all are definitions. Then in motion, what we can say? here in then conversion of degree Celsius to what we can say Kelvin, that you have to remember. Physical state of water at 25 degrees Celsius, 100 degrees Celsius, 0 degrees Celsius or 50 degrees Celsius, be perfect with that. Okay, then when it comes to motion, definition of speed, velocity, acceleration and their SI units, definition of distance, displacement, SI unit, difference between speed, velocity, difference between distance and displacement, difference between scalars and vectors. And after that, graph, those three formulas very much important. Out of that, one derivation from graphical representation. And after that, one compulsory problem from solved examples. So these are the very much important things we discussed. And apart from this also, there might some questions come. But whatever I discussed here, the questions in last or in two revision classes, I will guarantee you 16 mark. More than 16, 15 or more than 15 mark will come from whatever the questions I told now. Whatever the questions I discussed in last 3 to 4 minutes and last two video classes, they will come from more than, those questions might come from more than 15 marks. So remaining, you do your all the best, and after exam, please send the answer sheets to my WhatsApp number. It is already with you, and you have to keep those answer sheet with you, because you have to submit those hard copies on Saturday ಬರುವತ್ನಾಗ hard copies ನಮಗೆ ಕೊಡಬೇಕು. Okay, so I hope everything is clear. So ಬರೀ ವಾಟ್ಸಪ್ ಒಳಗೆ ಮಾಡಿ ಬಿಡಾಕ್ ಹೋಗ್ಬೇಡ್ರಿ. Saturday ಬರುವತ್ನಾಗ ಹಾರ್ಡ್ ಕಾಪೀಸ್ ನಮಗೆ ತಂದು ಕೊಡಬೇಕು. So wish you all the best for your exams. Do well. Thank you.